Okay, so now discuss about the directory implementation. So the selection of directory allocation and directory management algorithms significantly affect the efficiency and performance reliability of the file system. So how a file is created, how efficiently it is being retrieved, and how we manages it, it has a great impact onto the system performance because our actual data is being stored onto the secondary storage. So file system has to be very efficient to deliver the best of the system performance. There are some approaches that those are used for managing the directory structure or lists. So the simplistic one is a linear list. So of the file names and the pointers to the data block. So this is one way of storing the information, which is simple to program, but it is very time consuming to execute because we need a linear search. So all of you have done 160p 164. So in that you worked on linear data linear lists, or also you worked on linked lists, so you know that the performance of algorithm and the searching is uh, impacts the basically the information retrieval. So similarly, the linear search is the bottleneck for linear lists. So we could keep the ordered alphabetically by linked list or by using of the B trees. So B trees are the one which are used, which are very efficient. Then the advanced version of these trees are used for maintaining the directory information or implementation. So to create a file in linear list, we must search the directory to be sure that no existing file has the same name, and then we add a new entry at the end of that directory or the list. So we'll first search the list to find out the same name. If it is not there, then we add a new entry at the end. To delete a file, we search the directory for the named file and then release the space allocated to it. And we may use different ways of doing, just as used unused bit to reuse the directory entry which we have already created rather than deleting it. So that one method is used unused, other method is putting a special character on that place so that we can identify, okay, this is unused list, so we can put it there. But the real disadvantage of the linear directories, linear list of directory entries, is finding the file, and as it requires the linear search. So it is not good for, you know, um, if we say we have to do the random access. So whenever this is a linear search, the random access is not possible. This is very good for sequential search. So when we have to go from A to Z, then this is very good implementation. Then another implementation is hash table. So hashing, hash set you have created in CP104. You worked on that. You compare their performance. They are very good and very efficient. So hash table can be used for creating a linear list. So linear list with hash data structure is created. It stores the directory entries, but the hash data structure is also used. Hash table takes a value for the file and computes its hash value, and now returns a pointer to the file name in the linear structure, and therefore it can greatly decrease the directory search time. So as we know, the best time is O1, so it is always direct access to that particular entry. It is very good in case of hashing, and only good if we have fixed size, and the problem is a collision. So you know how we can remove those collisions in the situation that two file names could create a same hash value. So in that case, in CP1 of 164 also we use chained hashing. So that can be used because each and every entry could have connected a linked list for multiple entries for the same hash value. So that could be, that data structure could be used to efficiently implement the directory structure or listing. Thank you.